Okay, we just obtained this rather strange looking set of solutions where we have i's in the exponent, I being the square root of -1, and we don't really know what it means to raise e to a multiple of I, a power that's equal to a multiple of I. So let's think about what that could mean. Now let's recall the Taylor expansion for the exponential function be e to the t is 1 plus t squared over 2 factorial plus t cubed over 3 factorial, etc. And if you don't understand this, you need to review the Taylor expansion, but it's a very straightforward expansion. You should also review the expansion of the sine and cosine functions, because that's where we're heading, as you'll see in a minute. Okay, now if e to the t is this, then e to the I theta is going to be just what we get when we replace t with I theta. So we're going to get 1 plus I theta plus I theta squared over 2 factorial plus I theta cubed over 3 factorial, and so on. Now, that's going to be 1 plus I theta. I theta quantity squared is going to be I squared theta squared. I squared is -1, so that this term is going to become negative theta squared over 2 factorial. This term, well, I cubed is negative I, as you can easily verify. So we're going to have negative I times theta cubed over 3 factorial. And this is going to continue. And you can work out the terms. My 3 here and my 3 there seem to kind of be interfering with each other, so let's put a little line of demarcation there. Okay, now you notice that every other term of this expansion is going to be a real number with no I on it, and every other term is going to be a multiple of I. So we're going to separate the real and the imaginary terms. We're just going to say that this is 1 minus theta squared over 2 factorial, and that's going to go on. If we write out more terms of this expansion, we can see what the next terms are going to be here. The next one will be plus theta to the 4th over 4 factorial, and the next will be negative theta to the 6th over 6 factorial. I'm not going to write all those terms out. I'll leave that to you. But then this will be plus I multiplied by the terms that have I, which is going to be theta minus theta cubed over 3 factorial, and so on. Now, we might not have written out enough terms to see exactly what this series is going to be and what this series is going to be, but it's clear we're going to have a series here, and it should be clear it's going to be a series of even powers of theta, because again, every other power is going to have an I squared or an I to the 4th or an I to the 6th here, or an odd power of I here. And I'm going to simply note a couple of important expansions. Sine theta is, let's get a better pen. Sine theta is going to be 1 minus theta squared over 2 factorial, and I've got that wrong. That should be the cosine of theta. 1 minus theta squared over 2 factorial plus theta to the 4th over 4 factorial, and so on. And sine of theta is going to equal theta minus theta cubed over 3 factorial plus theta to the 5th over 5 factorial, and so forth. Again, writing out more terms of this series, you can verify that the real part, the terms you get from the real numbers, from the real multiples of theta, will give you the rest of the expansion of the cosine of theta, and the odd powers of the multiples of I are going to give you the rest of the expansion of sine theta. This leads us to the conclusion that e to the I theta equals cosine theta, because the cosine of theta is the real part. And then the sine of theta is going to be the terms that have the I in front of them, so that we have I sine of theta. And this identity is going to help us make sense of expressions like e to the square root of 6it. E to the square root of 6it is e to the I theta if theta happens to equal the square root of 6t. So we could write this term out using this identity, and we'll go on with that in a minute.